friends. So today we'll see the next question in LeetCode 75 series. So let's go to the question. And yeah, the next question is max number of k-sum pairs. What question says that you are given an integer array nums and an integer k. In one operation, you can pick two numbers from the array whose sum equal to k and remove them from the array. Okay, we need to pick two numbers whose sum equal to k, and after that we need to remove them and return the maximum number of operation you can perform on the array. Basically, maximum number of pairs whose sum equal to k that we need to find. And yeah, the similar question we have seen, that was the two sum pair, like two sum, in which we need to find the indices. But here they don't said about anything about the indices. So the approach coming in my mind is sorting, because they don't said anything about the indices. So basically it is a second version of, like, we can say the two sum 2.0, we can say it's next version for the two sum. We just need to find the two numbers is equal to the target sum, then need to remove it, and then again need to find the second pair, then we need to remove that pair, and likewise how many pairs are there in the array, I mean in nums vector, that we need to return. And here the target sum means k. Okay. Yeah. I told you the brute force optimal approach, like after sorting, that what I was saying. But yeah, the thinking process that first came in my mind was without sorting, how we can do without sorting, that I was thinking, but it took more time than sorting, and that the approach was without sorting is take a number from a nums and find a second number whose sum equal to, who's adding that number to the current number equal to k, and then increase the result count and make that both number equal to 0, and go to next like break it and go to next. Likewise, why I was thinking to take two for loops, and then we can do that. If I don't want to sort the array, then I was thinking to do that. Then second approach come in mind without sorting is using a map. What I can do in one pass, like take a unordered map, and then store that number and take a difference k minus that number, and if that difference is present, it means we have the number to which if I add the current number, then I will get the current number, that target number, that is k. So in one pass only we can add that just check that number in that, if it is present in that map or not, and if it is present in that map, then take that and decrease the frequency of that number in that map, and go likewise go on. So we can do that also, but in that case we save the time of sorting, but ultimately we are using the extra data structure, that is map. So I think in that case, if a number is not repeating, then it will take big of n space. And my fourth approach is sorting. Just sort the nums and then get the pairs. And yeah, that will gonna code here, and let's see how we can solve the question using fourth, like the last approach that I was saying ki first sort the numbers. I'm saying sort because they didn't said anything about the sequence of the numbers or the indices of the numbers. That's why I'm sorting it. And I will use your two pointer approach, left and right, where I'll add the left and right number, and if it is greater, then just decrease the right pointer, because I want less number to get the sum equal to k. So likewise, if the sum is less, then increase the left pointer, because I want greater number to get the sum k. And if it is equal, then um, increase the left counter, decrease the right counter, because I got the sum and I don't want any two because they told ki remove them from the array, so I need to drop both them. So I reduce the right pointer and I will increase the left pointer. I'll increase the answer and likewise I'll do. So yeah, let's do that whatever I said. Sort the nums and take a pointer left is equals to 0 and right is equals to nums dot size minus 1. And while my left is less than right, I'm not taking left is equals to right because we want two different numbers because they have said you can pick two numbers from the array in one operation. So two different numbers we need to pick. So L should be less than R. When the L is less than R, what I want, I will sum that numbers nums at L and plus nums at R. And if let's take my best condition. Before that, let's declare the answer vector, that what will be the result for this operation or for this question, for this function that we're gonna return. That will be the, I'm storing it in a result, and result is equals to 0. Or we can say not a result, it's not sounding cool, so we'll take count. Int count is equals to 0, and then we'll see ki if the sum equal to k, that's what we want, so we'll increase the count. That's the count we want to increase. That's if sum equal to k, then increase the count and decrease the right pointer, increase the left pointer. And yeah, if else else if sum is less than k, then what I want greater number, so just L plus plus. And else it means ki sum is greater than k, then we will decrease the rate R. If sum is greater than k, we obviously need the number which is smaller. That here, as it is sorted in ascending order, we have the greater number at R, and we need a number which has less value than the last number, that number at that R point. So we'll decrease the R, and likewise we'll do, and after that we'll return the count. Let's run it. And yeah, let's submit it. Okay, put 0, expected output 2. What can be, yeah, sorry, my bad. I did nums dot begin and nums dot begin. It should be nums dot begin and nums dot end. So use this test case. I don't know how it's happened, but it's human error. Sometimes happens. So yeah, it's accepted. And the time complexity for this question is, this sorting takes n log n. So n log n, here n means size of the array, and for this loop it will take big of n log n plus n. And yeah, so overall time complexity will be n log n. And let's take space complexity. For this, we are just storing this variable, so it will be constant. So space complexity will be big of constant only, big of 1. And the time complexity is also big of n log n. My bad, I wrote only n log n. Its time complexity will be the big of n log n, and space complexity will be the big of 1. Yeah, that's for today, guys. And yeah, I hope I explained it well. So yeah, bye.